Hello again, everybody. This is Coach Knight. Today we're going to learn about finding trig functions for any angle. We start off having a circle, and basically we're going to take what has been being our right triangles and we're going to put them into the coordinate plane with the x-axis and the y-axis. As you can see here, I've got four lines drawn from the center, four rays rather, and they are making angles. And so we're going to have a red theta and a blue theta and a green theta and a yellow theta. And basically we're going to find the sine, cosine, tangent, cosecant, secant, and cotangent of all four of these. They are related. We're going to talk about that. Every angle basically in each quadrant, and there's four quadrants. You have quadrant 1, the top right. Quadrant 2 is in the top left. Quadrant 3 is in the bottom left, and quadrant 4 is in the bottom right. It goes counterclockwise, just like your positive angles do. Each quadrant, the sine, cosine, tangent ratios repeat each other. Now, they may have a different sign, but they repeat each other, and I'll explain that as we go. So you can't really do the thing we originally learned, SOHCAHTOA. So sine is opposite over a hypotenuse, and cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So I said you can't do it. You can do it. You'll just have to draw your triangle. However, I'm going to show you both ways. We're going to draw a triangle, and I'm going to show you these new ways to find all six of them. Basically using your x and y of a point on the grid and the radius of your circle. So, first off, let's say this red one. If I were to draw a right triangle, and you always draw the triangle with the x-axis, okay? You just go straight down to the x-axis. This is my x, and this is my y, and this is my radius, okay? So, as you can see, my x, if I count it, is 1, 2, 3, and my y, if you count it, is 1, 2, 3, 4. So this point up here is at 3, 4. And 3 is my x, y is my 4. For r, you do the Pythagorean theorem because it is a right triangle. So r will be the square root of x squared plus y squared. And in this case, r is the square root of 3 squared plus 4 squared, which r is 5. And hopefully you remember our 3, 4, 5 triangles. You got 3, 4, and 5. 3, 4, 5 triangle. Okay, that's a very, very common right triangle. And basically there you just have to know these. You have y over r, x over r, y over x. And then of course for the reciprocals, you just flip all of those. Cosecant is r over y, secant is r over x, and cotangent is x over y. So the way I remember them is I'm going to erase these and rewrite them just because they're ugly. The way I remember them is you rock. Excellent, rock. You excellent. And if you say it with kind of a surfer boy accent, it'll be easier to remember. You rock. Excellent, rock. You excellent. I don't know. That's a very, very bad example, but kind of Keanu Reeves Matrix for you. You rock. Excellent, rock. You excellent. Bill and Ted's Excellent Adventure, if you've ever seen that movie. Anyway, that's how I remember that. Y over r, x over r, y over x. And then for the other three, you're just flipping them. They're reciprocals. So, to show you how this works, you take your y, which in this point right here, the red point, is 4. Over the radius is 5. Your x is 3 over 5. And your y, 4 over your x, 3, 4/3. And then for the other three, you just flip them. So that's going to be 5/4, 5/3, and 3/4. Boom, done. Now I want you to notice that your SOHCAHTOA still would have worked, okay? Sine would be opposite. Opposite is 4 over the hypotenuse is 5. So sine is still 4 over 5, and it works for the rest of them, okay? For the blue theta, again, draw my triangle straight down for the x-axis, okay? And you will see also that this point is -3, 4. So this is still a 3, 4, 5 triangle. It's just in a different quadrant. So that means your sine, cosine, tangent, cosecant, secant, and cotangent are still going to be the same. It's just, since it's in a different quadrant, some of them are going to be a different sign. So what do I mean by that? Well, here we go. This is x, this is y, 5 is still r. Okay, so for the sine would be 4 over 5 again. Notice, exactly the same as the other sign when we did the red. Okay, cosine, -3 over 5. It's also the same number, but this time it's what? It's negative. Okay, that's because it's in a different quadrant. And then y over x will be 4 over -3. Again, same fraction, but it's negative this time because it's in the second quadrant. Cosecant, we just flip them, so that'll be 5 over 4. Secant will be 5 over -3. And cotangent will be -3/4. Again, cosecants are the same. Secant and cotangent are now negative because we're in quadrant 2. For the green one, its point down here, again, go straight to the x-axis. Draw you a triangle. This point down here is going to be -3, -4. So we're in quadrant 3 this time. Same things apply. You rock. Excellent rock. You excellent. So my x is -3, my y is -4, and guess what r is? It's still a 3, 4, 5 triangle. Okay? So y is -4 over 5, x is -3 over 5, and tangent is -4 over 3, -4 over -3, which is positive 4 over 3. Okay, if you notice, the radius is always positive. Okay, you will never have a negative radius. Cosecant, you just flip the sign, so that'll be -5 over 4. Secant, -5 over 3. And cotangent is +3 over 4. And then last but not least, our yellow one. Again, draw you a straight line to the x-axis to make your triangle. This point right here is 3, -4. It's in the fourth quadrant. My radius is still going to be 5. And we go. You rock. Excellent rock. You excellent. So y is -4 over 5 is my radius. Cosine is x over r, which is 3 over 5. Tangent is -4 over 3. Y over x. And then you just flip them. So -5/4, +5 over 3, and -3/4. And there you go. Now, I want to show you a little trick, a little thing to help you remember which ones are going to be negative and which ones will be positive. Okay? It helps. It's not hard. You are probably in a trig class or some sort of class that's studying trig right now. So if you will remember this little quadrant right here and this little saying, all star trig class. And what that tells you is that in the first quadrant, all of them are positive. If you notice, our red, this was the red quadrant, okay? I'll underline it in red. Okay, the red quadrant, they were all positive. Sine, cosine, tangent, cosecant, secant, cotangent. They were all positive. In the quadrant 2, the blue quadrant over there, star starts with S. Sine starts with S. Notice, sine is the only one that's positive. And of course, cosecant is also positive because it's the reciprocal of sine. Everything else is negative. Okay? In the green triangle was in quadrant 3, trig starts with t. So if you'll notice, tangent was the one that was positive in quadrant 3. Okay? And then last but not least, class. Class starts with C. C stands for cosine. So if you'll notice, cosine and secant are the only ones that are positive in quadrant 4. And that's always the case. From angle 0 to angle 90, your trig functions or your trig evaluations, they just start over going as you go around the circle. So every time they get to a new quadrant, they start over again. Okay? So once you get out of quadrant 2, you start in quadrant 3, they repeat. You get the same decimals or the same fractions. It's just sometimes they're going to be negative and sometimes they'll be positive. Okay? So if you're doing, let's say number 1 here, this saves you a little time because you don't have to draw out the triangle. You just have to remember, okay, how do I get r? I know x is -4 and I know y is 3 because it says let -4, 3 be a point on the terminal side of an angle theta in standard position. That just means in standard position just means it's in the coordinate plane. Evaluate the 6 functions of theta. So all we're going to do is find r. Again, r is going to be the square root of x squared plus y squared because it's just the Pythagorean theorem. Now, I already know this one because, again, we've been doing 3, 4, 5. It won't be a 3, 4, 5 triangle every time, but it is for this purpose. So 3 squared plus -4 squared, that will be the square root of 25, which, okay, now I know r is 5. Now I can find everything. So I come over here, I say sine of theta, cosine of theta, and tangent of theta. You rock. Excellent, rock. You excellent. And we just plug in. So y is 3, r 5. X -4, r 5. Y 3, x -4. Boom. Cosecant theta, secant theta, and cotangent theta. You just flip your sine, cosine, and tangent. So cosecant will be 5/3, secant will be -5/4, and cotangent will be -4/3. Now, if you'll notice, just to show you that everything checks out, if you were to graph -4, 3, it's 1, 2, 3, 4, 1, 2, 3. It's up here. It's in what quadrant? It's in quadrant 2. And if you'll notice, remember, all, star, trig, class, which one's supposed to be positive in quadrant 2? Sine. Well, you'll notice that the sine and the cosecant are the positive ones. Everything else is negative. Okay? And that happens every single time. All right? Moving on to number 2. Number 2, it's asking us to use the unit circle. Now, unit circle, right here. That is simply a circle that has a radius of 1. Okay? So this circle has a radius of 1 all the way around. Radius is 1, radius is 1, radius is 1, all the way. Okay? Now, so what does that tell us? That tells us that this point right here is 1, 0. This point right here is 0, 1. This point right here, -1, 0. And this point is 0, -1. Okay, so all the way around. So when you go to find the sine, cosine, tangent, cosecant, secant, and cotangent of 270, well, you go to 270 degrees. It's right here. And so we use point 0, -1. There's x, there's y. You do your you rock, excellent rock, you excellent, and you plug in. Okay? So y is -1, r is 1, -1 divided by 1 is 1. x is 0, r is 1, 0 divided by 1 is 0, y is -1, x is 0. You can't divide by 0, so that is undefined. And then you flip those to get the reciprocals. So 1 flipped is 1, secant flipped or cosine flipped is 0. If you flip 0, you get undefined. It puts 0 on the bottom. Undefined flipped would be 0, because if you flip undefined, you put 0 on top. Okay? So, next one, we're finding theta is -270. First one we found, theta was at 270. This one we're doing -270. So all that means is we're going in the other direction. So -270 degrees is actually up here at 90. Think of it going clockwise. Remember, clockwise is negative, counterclockwise is positive. You could also, if you wanted to, add 360 to it to get a coterminal angle of 90 degrees. That's where you end up. And there's your x, and there's your y, and like we said, it's a unit circle. R is always 1. So we're still going to get y, you rock, excellent rock, you excellent, and we plug in. So y is 1 over r is 1, that's 1 again. X is still 0 over 1, that'll still be 0. 1 over 0 will still be undefined. As you can see, not much has changed, except, oops, I messed up over here on the sine of 270. I said -1 over 1 is 1. -1 over 1 is -1. Sorry about that. All right, back here to -270. If you flip 1, you get 1. If you flip 0, you get undefined. And if you flip undefined, you get 0. And I found another mistake on this first one over here. This cosecant, if you flip -1, should be -1 as well. So as you can tell, basically you get the same answers. It's just some of them are negative on 270, and they're all positive on -270. Okay? So, number 3 says find the reference angle theta prime for A, theta is 5 pi over 3, and B, theta is -130. So there's a process to find the reference angle. And all the reference angle is figuring out which one of these, which quadrant your angle is in. So it's basically taking a really big angle and making it something between 0 and 90. Okay? You're going to make the angle, whatever it is, something between 0 and 90. You're going to find its reference angle. And here's how you find the reference angle. So I have this labeled alpha. I'm going to change this to theta right now because we're using theta. It doesn't matter. There's theta, 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 theta. Okay? So basically all this theta is talking about is your angle. Okay? So if it's in quadrant 1, your reference angle is itself. It's going to be theta. If it's in quadrant 2, your reference angle will be 180 minus theta. If you're in quadrant 3, your reference angle is going to be the angle minus 180. And if you're in quadrant 4, your reference angle is 360 minus theta. So for part A, first thing we have to do is figure out what is 5 pi over 3 in degrees. And so degrees are a lot easier to work with. I'm just going to change it to degrees here real quick. The pi's will cancel. 180 divided by 3 is 60 times 5 is 300 degrees. Okay, that's step 1, getting it in degrees. Step 2 is figuring out what quadrant would that degree be in. Okay, so in this case, we're already between 0 and 360. So the angle needs to be between 0 and 360. And once you figure out what quadrant it's in, 300 would be in quadrant 4. Okay, 270's right here, 360's right here. So 300 is in quadrant 4. So basically you just plug it in and say 360 minus 300. And so my reference angle will be 60 degrees. Okay? That's all there is to it. For part B, we're trying to find the reference angle for negative 130 degrees. Okay? So all you do, first, negative 130 is not between 0 and 360. So the first thing we have to do is get it between 0 and 360. So we have to find the coterminal angle first. We're going to add 360. That will be 230 degrees. Now we can find our reference angle. 230 would be in quadrant 2, or quadrant 3, excuse me. It's between 180 and 270. So we're going to use theta minus 180. 230 degrees minus 180 degrees. Theta prime, or the reference angle, that is 50 degrees. Okay? So, and basically all that's saying is, if you find the sine of 230 degrees, you're going to get the same answer as if you found the sine of 50 degrees. Okay? They are the reference angles. Now, it might be positive or it might be negative. In other words, the sine of 230 and the sine of 50, they're going to be the same number. They just might have different signs. Okay? So it might be a different decimal or different fractions, but they may have, one might be positive, one might be negative. Okay? But here, all we're finding is the reference angle. Okay? So our last problem, number 4, says to evaluate the tangent of negative 240 and the cosecant of 17 pi over 6 without using a calculator. So that's the key. Without using a calculator. Anybody can type these in their calculator and get it. So anytime the question's asking you to do it without a calculator, 9 times out of 10, they are wanting you to break it down into a reference angle, and that reference angle will be either 0 degrees, 30 degrees, 45 degrees, 60 degrees, or 90 degrees. Those are the 5 most common angles that you are kind of expected to just be able to know it in your head. You don't need a calculator to do it. Okay? So, before I explain to you the hand, and it's the left hand, you're going to use your left hand to help you do these problems, okay? So, for sine, let's just, I'm going to do an example. Let's say we were doing 45, okay? So, 45 degrees. That's the middle finger. Basically, all you do is you take the number of fingers to the right. How many fingers are over here to the right? 1, 2. And you take the square root of 2 divided by 2. Everything for sine and cosine are both just divided by 2. So the sine of 45 degrees is equal to square root of 2 over 2. If you did the cosine of 45 degrees, well, for cosine, you do the number of fingers on the left. Well, there's also 2 fingers on the left. So that's going to be square root of 2 over 2. For tangent of 45 degrees. Tangent, you do the number of fingers on the right, the square root of the number of fingers on the right, divided by the square root of the number of fingers on the left. So that's going to be square root of 2 divided by the square root of 2, because there's 2 fingers to the right and there's 2 fingers to the left. So the tangent of 45 is just 1. And that's how you do it without using a calculator. Okay? Let's do another one real quick, just quick before we do these problems. So let's pick another. Let's say 60 degrees. Okay? If we're doing 60 degrees, that's our pointer finger. So you can put it down if you want to or leave it up. It doesn't matter. You just do the sine of 60 degrees. Well, to the right of 60, we got 1, 2, 3 fingers. So the square root of 3 divided by 2. Done. For the cosine of 60 degrees, well, there's only 1 finger to the left of our 60 degree finger. Okay, so that's square root of 1 over 1, or excuse me, over 2. And the square root of 1 is 1 divided by 2. So the cosine of 60 is 1/2. The tangent of 60, again, we have 3 fingers on the right, square root of 3 divided by the square root of 1. And again, that's just square root of 1 is 1, so that's square root of 3. So the sine of 60 is square root of 3 over 2. Cosine of 60 is 1/2. Tangent of 60 is square root of 3. Okay, so how are we going to use this on our problems? Because if you see over there, tangent negative 240 is not 0, 30, 45, 60, or 90. Okay, so, but it is. Let me show you how we get there. We have to find the reference angle for negative 240. Okay, so we're taking number 3 that we just did where we found the reference angle. We have to do it for this. Okay, so negative 240 is not between 0 and 360. So we have to find a coterminal angle first that's between 0 and 360. So we're just going to add 360. 360 minus 240 is 120 degrees. That's our first step. Get an angle between 0 and 360. You have to do that before you get your reference angle. Okay, so theta has to be between 0 and 360 degrees. Okay, so that's 120. And you ask yourself, what quadrant is 120 in? I'm just going to tell you what. I'll do this. I'll draw us one here. So there's 90, 180, 270, 360. Okay, and of course 0. All right, so 120 is in quadrant 2 over here. And so if you remember, if we drew an angle and we called that 120, you're basically asking yourself, how much further do you have to go to get to 180? And the answer is 60. Okay, now the way we did it here, we just used our, oops, wrong one, not quadrant 2. We use our quadrant 2, which is 180 minus theta. So we're going to say 180 minus 120, and we get 60 degrees. Okay, so basically we're just going to find the tangent of 60, but we're just going to use 60. We're actually still finding the tangent of negative 240. So watch how I do this. I'm going to take 60, and we're going to find the tangent of it, which we just did a minute ago. So remember, tangent is the number of fingers on the right, square root of number of fingers on the right. So there's 3 fingers on the right. So the square root of 3 fingers divided by how many fingers are on the left? 1. The square root of 1. So that will be the square root of 3. However, what quadrant are we in? Remember, all star trig class. So tangent in quadrant 2, remember the only one that's positive in quadrant 2 is sine. So this has to be negative. Negative square root of 3 would be your answer. Okay? 17 pi over 6. Good gracious. So we got a lot to do to this one, because first we're going to make it a degrees. Okay? Get it out of that, goes radians. And when we do that, we'll figure out what that equals. If you put that in your calculator, you'll see that it's the cosecant of 510 degrees. Okay? Now, is 510 between 0 and 360? It is not. So we need to subtract 360 from that. So basically, we're going to be taking the cosecant, let's see here, 510 minus 360 of 150 degrees. Okay? And now we figure out, all right, what quadrant is 150 degrees in? 150 degrees would also be in quadrant 2. So we're going to do cosecant. If you'll remember, it's the reciprocal of sine. So if sine is the square root of the number of fingers on the right over 2, then cosecant, oh, I'm sorry, we didn't find our reference angle yet, did we? 180 minus 150 is 30 degrees. So that's our reference angle. So we're going to use 30 right here. And rather than doing cosecant 17 pi over 6, rather than doing square root of 2 of the number of fingers on the right divided by 2, we're going to flip that and do 2 divided by the number of fingers, the square root of the number of fingers on the right, which is, there's 1 finger over here on the right, okay, from 30 degrees. So that's just equal to 2. Now, where are we at? We're in quadrant 2. So again, the ones that should be positive in quadrant 2 are sine and its reciprocal, cosecant. So we leave this as positive. If we had been getting the cosine of this or the cotangent of this or the secant of this, we would change that 2 to a negative. So I know this was a lot to put in one video. I hope you understand it. And as always, stay above the line. Y'all have a great time doing these, and hope you learn a little bit and love trig as much as I do. Have a good day.